Hi. So now let's look at another LeetCode problem. This is on NeetCode platform. Okay, so now we are looking at this problem. Actually, let me quickly check what is the problem number. Graph valid 3. Graph valid 3. So it should be problem 261. Okay, so let's take the problem 261. I will jot down my paper. Graph valid 3. Okay, now given n nodes labeled from 0 to n minus 1 and a list of undirected edges. Each edge is a pair of nodes. Write a function to check whether these edges make up a valid 3. Okay, so let me write down some nodes and read the problem to make sure I understand it. So we have n nodes. Zero to n minus 1 and a list of edge. List of edge. Now we need to return if this is 3 or not. Okay, so I think I understand the objective here. Now let me go look at the examples there. Example 1, x is 5 and is 5. Edges is, let's see, edges are 0, 1, 0, 2, 0, 3, and 0, 4. Oh, sorry, 0, 1, 0, 2, 0, 3, and 1, 4. Okay, now let's try to draw this up. So we have 0 points to connected to 1, 0 connected to 0 connected to 3, and then 1 connected to 4. So it looks like a 3. So I'm going to return true. Second example, n is 5. Edges are 0, 1, 1, 2, 2, 3. Let me just write it down in a write it down as a list so it's easier to see. 0, 1, 1, 2, 2, 3, 1, 3, and 1, 4. If we draw this, we have 0 points to 1, 1 to 2, 2 to 3, 1 to 3, and 1 to 4, so it's true. Sorry, it's false. How is this not a 3? 0, 1, 1, 2, 1, 2, 3, 1, 3, oh sorry, 1 points to 3. I accidentally draw 2 3s there, so the answer is false because 1 connects to 3 and then 3 also has a edge to 3, which means that there is a cycle there. Alright, I think I understand the examples there, and it confirms my understanding. I would like to clarify a few things. To clarify, okay, first of all, what is the range of n? N is from 1 to 100 edges. Let me see, do I need that? Okay, how about we ask whether the edge is valid? Is there any repetition? So in here it says that there is 0 to n times n minus 1 over 2. Now you can assume that no overbroken edges will appear in the edges since all edges are undirected. 0, 1 is the same as 1, 0 and does not appear together in edges. So there is no duplicate. Alright, so I think we got all our we got everything that is relevant to know for now. And let me think of some possible approaches for this problem. So we want so the way we are going to determine that it is a 3 is by checking if there is a cycle there. But how do we know that there is no such cycle if we don't even know where to start? How about we start from any arbitrary point and then we do a BFS on that? Is that gonna work? So let me try. Because if we do a BFS and then it means that at some point we are gonna meet one of them. But these are all undirected unless what we have seen in the previous question. So I think it could still work. How about this? We could do a BFS and then once, because it is undirected, if we have go through an edge, then we remove it from our edge list to make sure that we have visited them, and then we will only visit them once. Okay, so now what we're gonna need is, so we build an adjacency list for this. I think So let's say we visit an edge, then we go to all the edges that connect to it. So we can remove it from our list of edge. And then what's next? Next thing we could do is, again, we do a BFS on all the edges and the neighbors. And then we see whether it is connected. So how are we gonna tell if it is connected? Okay, so it means that if there is an edge that connects to if we visit a node twice, then it means that there is a cycle. Okay, so how about this? Let me write down the step. Number one, the BFS on arbitrary node. Two, and then we mark visit. Two, BFS on neighbors. And we remove the edge. If neighbor in visit, then we just return false. I think this may work. How about we check our example? So for example one, let's say we start from 0. If we start from 0, then we remove all the edges, and then 1, 2, 3, we reach the end, which is 4, then it's true. It's how about we start at 0, true. If we start at 1, it is also true, 2 also true, 3 also true. Example 2, if we start from okay, so another thing that we need to check is that if n is equals to length of the visit, because otherwise there is a node that we haven't visited yet. Okay, now example 2, if we start at 0, then we will visit 1, 1 will visit 2 and 3, and at 2 we're gonna visit 3 again, which is already visited, so it's false. If we start from 1, it is also false. 2 also false. 3 also false. 4 also false. So I think I'm pretty good about this. I would like to start coding unless there is a further optimization that you would like me to explore. I think if I do a BFS, then it is gonna take us on time, on plus v times v time complexity. So I think I'm pretty good. Now let me go through the code. Let's see what we need here. So I build an adjacency list. I think So okay, so how about we use what is it called? Is it even adjacency list or Python? So what are the graph representation adjacency list or matrix? So I use an adjacency list or a matrix. Adjacency lists are generally preferred for sparse graph with few edges due to their space efficiency. So I think in a tree, it's gonna be the edges is gonna be sparse because we hope that there is no cycle there. It means that if there is no cycle, then there are not a lot of edges there. So let's just use an adjacency list then. How are we gonna do this? We're gonna use a set. So I'm gonna create let's see, let me call the adjacency list as a neighbor. So neighbor is a default type of set. There we are gonna go through all the edges for let me just call it, say, x and y. So for x, y in neighbor, sorry, it's in edges because that's what we call the variable. Then we add to both the neighbor. So neighbor.x, we add the y. Neighbor.y, we add the x. Then we have to do is that. Then let's just add the 0 there. And 0. Now we're gonna do the VFS. While to do current equals to-do.pop. Alright, now don't forget to create the visit set. After we pop it, we add to our visit. Okay, first of all, we check if it is visited. If cur in visit, return false. Otherwise, we add it into our visit. Dot add current. Hold on, I'm a bit confused here. Okay, I think it should work. So I was just thinking that if we remove the edge from it, then there won't be any cycle anymore. But then at some point it's gonna, if there is a cycle, then there is a point where we visit a node twice. So I think that should work. Yeah. Okay, so I think I need to create much more example. So example 3. Okay, first of all, for the example 2, let me go to that again. 0 visit 1. And then we will have 2, 3, 4 in our to do. When we visit 2, we add 3 to our list. And then at some point in the future, we are gonna pop 3 twice. Okay. Alright, I think that's it. So for next in neighbor of cur dot pop, and then we remove the edge from the corresponding edge. So neighbor of next dot remove cur. Then we append that particular node to our to do dot append next. Alright, I think that should be it. Finally, we return n equals length of visit. Now let me quickly go through the code again to make sure I don't miss anything. And we have the visit set and the neighbor dictionary using the integer value as a key and then the set as value. Then I'm gonna go through all the edges and add it into the neighbor dictionary. To do will be initialized with 0, so we are gonna start it from 0 by default. Inside our while loop, it will pop a node at a time, and then we mark it as visit. Or if we have visited before, then we return false because there is a cycle there. And then we add to the visit. Now we go through all the next node that we can visit. So we pop it one by one and remove the edge from the corresponding next node to visit so that we don't revisit the same edge twice. And then add it to our to-do. In the end, there should be n nodes in the visited set. Otherwise, there is a node that is not connected to the tree. Now let me check with our input example to make sure it works as expected. Example 1, we start with 0.2, 1, 2, 3, and then we check that 2 does not have anywhere else to visit. We pop it out, pop it. Also do the same for 3. Now we have 1. 1 has an edge to 4. We visit the 4 and everything looks okay. And we have visited 5 nodes, which is expected. For example 2, we have 0, then we have 1, then we have 2, 4, and 3. Let's just say we managed to go on 2 first. So 2 will add 3 into our to-do. In the end, there is a point where we pop out 3 twice, meaning that we visit 3 twice. So that will be false. Okay, so I think this should work. Now let me input our solution into NeetCode to make sure it runs as expected. Neighbor equals default tick offset for n1 and 2. I think m and n is better name. In edges neighbor of x dot add y neighbor of y we add the x. Then to do will be a deck to do dot append 0 and to do cur equals to do dot pop if cur in visit return false. Otherwise, we add it to our visit. And then what we're gonna do is we check all the neighbor for next neighbor of cur dot pop neighbor of next dot remove the cur, and then we add it into our to-do. In the end, we check whether the n is the length of all the visited. Let me try to run this. Neighbor. So it's not neighbor but neighbor. Neighbor. is not defined. Okay, I'm using m and n, and n. What else is wrong here? Maybe it's a bit hard to spell. In object is not iterable. I think I don't need to do that. But then let me check. Python port set. Okay, I got a wrong answer. Should I return false? So why is that? Let me print the code and fix it. Zero and then 3. Do code and fix it. That and then 3. Then we visit 2 and then we visit 1 and then we visit 4. So 4 is not visited yet. Okay, so it's not n, I got it wrong. So n, okay, so I cannot use an n here. Right. Okay, let's go back to x and y. Or actually, let's just use ref and curl, it doesn't matter anyway. Yeah. Now let's try to submit it. We got a wrong answer. Set string size. Is it because of a cycle? Oh, I see. So I think what we can do, so I think I made an assumption here. So let me, how about if I check it here, if curve return false. Yeah, now we got it right. So let me jot that in our notes. It's a warning. What is it called in a self-pointing cycle? Graph self-cycle. Okay, self-loop. Self-loop. There is not a cycle, but a self-loop. Okay, I think that would be it. We cannot see other people's solutions, but you can go ahead and review solutions from NeetCode. Cycle detection, BFS, and disjoint set unit. Do I need to do that? So what I'm doing is basically a cycle detection. What is it? BFS, but anyway. I think a BFS could also be used for cycle detection anyway. So the phi plus E. So the disjoint set union is more space efficient. So I suggest that we could look into it later. I might as well create a second attempt for this. But in here in this video, we will stop it. Thank you everyone.